Next thing I'm going to talk about are the tetrapods, amphibians like anurans, salamanders, and caecilians. I'm going to talk a little bit about the global amphibian decline and how chytrid fungus is a major culprit in that. So first of all, frogs and other amphibians are relatively sensitive to environmental conditions, and that's because they're vulnerable to desiccation. They breathe through their skin. Their eggs are soft and can dry out, and they require specific habitats. Aluminum, cadmium, and copper are all toxic to amphibians. And there's so many things that are causing amphibian declines. The first is wetlands, wetland destruction, and wetland mitigation. So destroying natural wetlands and building uh, fake wetlands that probably don't serve the same function. Over 50% of US wetlands have been lost since 1600. Things like forestry and logging, particularly in neotropical regions, water alteration, so things like dams, floodplain destruction, levees, these all cut amphibians off from important habitat. And there are so many dams worldwide. It's a good sign that we're taking some of them down, but we're also still building new dams all over the world. Things like urbanization, the percentage of impervious surface, agriculture, these are all things that lead to habitat destruction for amphibians, and then a whole host of changes due to climate change, warming of water temperatures, storms, increased droughts. And so there's a lot of studies out there that show this climate change may severely impact roughly a quarter to half of all amphibians. Other things that we think are possible causes of the decline are the increased UV radiation, which is an important interactor, tends to be absorbed by dissolved organic carbon. We think increased UV radiation can negatively influence egg success, and higher elevations are more prone to issues. Diseases, so things like the chytrid fungus, which is a really common fungus in all parts of the tropics in South and Central America, moving up here into North America as well. Things like ranaviruses, which are a family of viruses that affect amphibians, fish, and reptiles, and then just kind of random malformation. So in the 90s, students in Minnesota found that a lot of frogs in their local wetland were deformed, and they wondered why. Well, it turns out there's several potential causes, but one is a parasite. So this is the trematode fluke. It has an initial snail host, and then it infects frogs and causes, you can see the growth of additional legs, which I'm sure is challenging for this individual to move around. And then a whole bunch of pollution and toxins. So all of these things, acid rain, pharmaceuticals, eutrophication, heavy metals, mining effluent, fracking fluids, pesticides. Because of the way amphibians work and their sensitive skin, these are all possible harmful components of ecosystems. Pesticides, I'm going to dig in a little bit because there's an interesting story here about atrazine, which is a weed inhibitor. We use about 80 million pounds per year, particularly in kind of the Corn Belt. Only Roundup is more heavily used as a pesticide, and it lives for a really long time in the environment, 2 to 100 days. This is Dr. Tyrone Hayes. He's an endocrinologist at UC Berkeley, a herpetologist. He studies frogs. And he found in the early 2000s that this waterborne herbicide, atrazine, is affecting frogs pretty dramatically and basically turning male frogs into female frogs. So disrupting their endocrine systems and shifting hormones and changing and causing hermaphroditism and other abnormalities. Well, unfortunately, I'm not going to go through this whole story because it's a really crazy saga, but I will give you a link to an article that talks about it. Atrazine is a pesticide that Syngenta created, and Syngenta first started off by hiring Tyrone to study the effects of the herbicide. Well, when he found effects that they weren't happy with, they fired him, and then they started a smear campaign against his science. And he kind of fought back as an advocate against Syngenta, and it turned into this really heated battle. He He lost control of his lab for a few years. The UC Berkeley system, they didn't necessarily kind of stand up for him, which was really disappointing. And all kinds of yeah, awful things happened. But the great thing is that fast forward to about 2014, he's really been vindicated. So this article in the New Yorker is a really great one if you want to learn more about this. But a class action lawsuit against Syngenta brought to light a conspiracy to discredit him as a scientist, but his lab is now back up and running and his credibility has been restored. But it was a really long challenge for him. So just a really interesting story about being a scientist and being an advocate and the risk that you take on when you do that, when it shouldn't be the case, because scientists should be able to speak freely about their findings. Okay, I'm going to stop.